Hello everyone, welcome to week 9 video tutorial. In this video, I'm going to take you through creating the Pokemon project from scratch. Here, I like to divide this video into several parts so that it can be more structured for you. So first and foremost, we need to set up the environment. So basically, we need WebStorm from JetBrains as our IDE, Angular CLI, and Node.js. Go to your web browser and open these 3 web pages and download the corresponding installation packages. As I've already downloaded the Node.js package, I would directly install it. For Angular, it is quite different from the other two due to the fact that it requires command line installation. So we would just do the npm install-g at angular/cli. You might encounter this kind of error. This is mainly because of the permission errors. Just add a sudo keyword before the actual command and run it. Once we've done the installation process, let's check our environment by typing npm-version and then g-version in the terminal. If you can see the same result as showing on my screen, you're good to go. So let's create a new folder to be our project container. So in my case, let's call it W9 exercise student. Open the WebStorm and create a new Pokemon project under this folder. So one of the greatest advantages for using WebStorm is that it comes with terminal, which means that we don't need to switch to another bash window to do the dirty work. In order to let Angular to create a project for us, we need to type ng new Pokemon, where the position of Pokemon is for the name of the project. Once the Angular has done the initialization process, we should be able to see this folder structure. Sometimes you might not be able to see the node modules folder inside the structure. If this happens, we need to manually type npm install to install all the dependencies which have been declared in the package.json file. Before you invoke the npm install, make sure your current location is in the project root folder, which in this case is the Pokemon. Now, let's try to run our project by calling npm start or ngserve and see if it works. Before doing that, make sure we are in the root folder. If you can see the same page as I am, it means our Angular project has successfully been created. As we've successfully initialized the project, let's go back to the WebStorm and create some necessary folders. In our case, basically we need data, model, Poke API and service folders under source app. The data is for holding the database file. Model is for the entity class. Poke API is the container of the Pokemon API component, and the service provides the additional functionalities which will be injected by other components. So now, after we have this structure, we actually need the TypeScript to hold the actual code. Create a Pokemon data service in the data, Pokemon in the model, and data service under service. After we set up all the file structure, let's do some coding stuff. In our Pokemon TypeScript file, what we need is a Pokemon model. You can consider it like a struct. Here, the keyword for declaring a class in TypeScript is export class. Next, for our database, it is implemented by having an array containing all the data. Here, we are actually using the in-memory database. What it does is that all the data in this array file would be stored into the memory when we run the project. Additionally, we also need to implement the data service in order to provide some additional functionalities, which in our case is the web service for interacting with the data to power the view. Let's create our CRUD component by calling ng-gc Pokemon CRUD. Please be aware that the file structure here is that one component contains an HTML file, a CSS file, a spec.ts file, and a TS file. The HTML file represents the view part. SCSS is responsible for the style of the view. The spec is for the unit testing, and the TS file contains all the logic behind the view. After we copy and paste those codes into the CRUD HTML and CRUD TS file, let's investigate how these components work together in Angular. Firstly, the index.html file can be considered as a master page. Let's include the Bootstrap CDN link to the index so that all the nested components can use Bootstrap. In the index page, you might notice the app root tag. This is the place where the root component is rendered. Let's now navigate to app.component.html. Here, this HTML file defines the view of the root component. We need to declare 3 buttons at the top of the page, which play like a navigation menu. Everything in the router outlet tag will be controlled by the app routing module, which means that when you pass the router link to the browser, it will automatically map the corresponding component into the router outlet tag by checking the root array in the app routing module. Since we have mentioned about the routine, let's add that path into our routes and map it to the Pokemon CRUD component. Since we injected in-memory database, reactive forms, and etc., we need to import them in the app module TS file. Basically, it's a class where to register all the components and import all the dependencies so that we don't need to import them repeatedly in different components. Here we encounter an error for importing the in-memory database. This is mainly because we haven't installed that package. A simple way to solve this is to add this package in our package.json file and run the npm install. Now let's go back to our module file and import the forms module, HTTP client module, and React Forms module. In addition, since we also invoke a method in our root page, we need to implement that onClick method in the app components TS file as well. Now let's run our project by calling the ngserve again. We should be able to see the CRUD function works perfect and instant. Let's try to add a new Pokemon, update it, and remove it. Since we've done with the CRUD function, now let's go back to our IDE and implement the API function. Shut down the server by Ctrl+C and go to the Pokemon API folder and type nggc Pokemon list to let Angular generate the list component for us, same as the Pokemon detail. After the process is done, we should be able to see the file structure as showing on my screen. Now, let's copy the HTML and TS file into the two components that we've just created. After we put in the code, navigate to the app.root.module.ts file to register those router link into the routes array so that it could be rendered in the router outlet tag based on the URL. Let's investigate how we can pass the ID as an argument from the list page to the detail page. Firstly, for the list HTML file, we can tell that in the router link, basically we put a /Pokemon as a prefix and followed by an index. The reason why we have additional 1 is because in TypeScript, the index always starts from 0, but in our case, we need to start from 1. This ID will then pass as an argument to the URL or path where we define as the third router in the routes array. Go to the list component TS file. It is clear that in the ngrinit function, where the methods will be invoked when the component is first initialized, we are trying to get the Pokemon JSON data from the public API using HTTP GET request. After we successfully pass the argument to the URL or path, let's switch to the detail TS file, and as you can see, we can get that ID argument from the URL and retrieve the corresponding JSON array from that API. Okay, now we've completed everything. We can just call ngserve or npm start to run the project, and we should be able to see everything works perfectly fine. Congratulations! To this stage, you have successfully accomplished your first Angular mission. Hope you will enjoy this video and thank you for watching.